So the main reason why we thought of healthcare management is because I believe during times like these, I believe a robust healthcare management is required, which provides individuals of all income groups an inexpensive cure. So our main objective was to primarily set up boot camps, which will be able to provide people within each city, state, and county immediate care at a minimal cost. So we will be setting up boot camps based on the smaller number of healthcare facilities, a greater number of disease outbreaks, high mortality rate, and the people affected in a particular city, state, and county. So the main CSV files which we dealt with were based on disease treatment, hospital CSV, and patient data. Next, we talk about the KPIs. The KPIs are basically the indicators that are crucial for a project. So first, we start with finding out different flu outbreaks. So with this KPI, we will be able to find out the different diseases in a particular city, state, and county. So by that, we can find out what kind of hospitals can be implemented in that particular area. Secondly, we can talk about the less people to hospital ratio. Suppose if a hospital has many patients which they can't take care of, so our boot camps will be able to provide them with the resources which they need to cure the people. Nextly, we talk about the high mortality rate. So basically, it would be the number of diseases, the rate at which the diseases will be the rate at which the diseases are mortal. So now let's talk about next slide, please. Yeah, so now let's talk about the data architecture diagram. For a data architecture diagram, the data sets which we deal were mostly in CSV files. We imported those CSV files and used ETL tool Talent, and we did the cleaning and data cleaning and profiling using Talent. After cleaning the data, we imported it to MySQL Server. After importing it to MySQL Server, we ran particular queries, which and then after running those particular queries, converted it to JSON path and imported into MongoDB. After importing it to MongoDB, we established a connection with Mongo charts and then based analysis on it. Next slide, please. Yeah, so here is our ER diagram. So here we have the three tables. Our crucial tables are patient, disease, and hospital. So a patient will give us the patient demographics in a particular area, which will include patient name, gender, income, patient contact, age, and etc. Similarly, a disease will have a disease ID, name, and category. Also, here you can see we have used embedding techniques. Suppose for disease table, as you can see, treatment details will be embedded within treatment details, as you can see. So treatment details will be having treatment cost, medicine charge, room charge, operation charge within the treatment details. Next slide, please. So here we have the talent job, wherein, as you can see, we have used the three different collections: disease collection, hospital collection, and patient collection. For the disease table, we have joined those two flat files, disease city and disease, based on the lookup function on a disease code, which is our code for our diseases. We have imported it into tmap and used the tunique row and stored the data into MySQL. Similarly, we have done for hospital collection and patient collection. Next slide. Yeah, so this is the query which we have used for embedding. So as the data was stored in the MySQL server in a relational format, we use the query given by professor, which, so here you can see, as we have used the alias to do the embedding, to perform the embedding. And you can see in the hospital collection, we have used the h1 alias and hospital address dot street. So as you can see, the street, city, and state and zip code for each hospital will be within the hospital address. And similarly, we have performed embedding for disease and patient. Yeah, now I'll let Nikhil continue for the next slides.
Thank you, Lionel. So after importing the data, so this is the embedded structure we have got. As you can see in the first collection, we have the patient ID, first name, last name, and all the other columns. And as you can see, the address column is embedded, like street, city, state ID, and state are embedded within address. And similarly, we have achieved embedding for hospital. As you can see, the hospital address field, the zip code, city, and state are embedded within hospital address. And similarly, total inpatient, total outpatient, total labs, number of doctors are embedded within hospital capacity details. Next slide, please. The next thing we move on to is map reduce functions. So to show some important analysis, we have performed few map reduce operations. So what this map function is doing is basically this is a JavaScript code, and we try to emit a particular column which we require for the analysis. As you can see in the first map reduce operation, we have used gender column here from the data, and count :1 indicates that every time the gender appears, the count will be updated for the particular gender. So MapReduce function will sort those values, group those values automatically. And in reduce function, what we will be doing is we have to pass the gender and count, and reduce function will count those values for that particular gender and group it in the reducer. So similarly, we have implemented this for state-wise hospital count and number of patients working in different domains. Next slide, please. And finally, we have done aggregation pipeline on the collections, and we have used the group parameter, which will be grouping based on code. And these are the columns which we have selected. As you can see, one of the examples, like we'll be adding number of cured patient, number of details, number of deaths, and average number of cured and average number of deaths. So we have obtained the output like this. Now we'll be doing a live demo for the MapReduce operation. Yeah, we are creating the variable for the map. Now we will write the map function. This is the map function. Can you write the reduce op? Yeah. This is the reduce function we have wrote. So after running this map and reduce functions, we'll get the output. Yeah. So as you can see, the number of females are 10,905 and male patients are 7,585 and others are 2. Yeah. Can you run the aggregate, one example of aggregate function? Yeah. So here we have aggregated pipelines to group the data by treatment code and calculate average treatment costs for these treatments. Yep. So now the visualization part will be explained by Kirti.
Hi, everyone. I will be walking through some of the insights that we created on Mongo charts to conclude our analysis. Um, so this is the dashboard that we created. Here, the map chart demonstrates the number of hospitals per in every state. So we can see that Texas has the most number of hospitals, closely followed by California. Then here in the bar charts here, we can see what we are trying to calculate is the treatment costs and mortality rates in different cities. So we can see that New York is leading in is spending the most in healthcare treatment, and New York also recorded the highest mortality rates, followed by Los Angeles. um, Moving on to some of the patient demographics, we can see here in the donut chart that most of the patients belong to the private sectors. Um, and moving on to the ratio between the doctor and patient, we can see that there are around 1 lakh 30,000 outpatients and 1 lakh inpatients, and around 12,000 doctors, which is not really a bad ratio, but except we are not in the middle of a pandemic. So and yeah, this stacked column chart shows us the cure to death ratio. California records the most cure to death ratio, followed by Texas. And we also did some analysis on the hospital collection. So here we can see that the most hospitals are owned by non-profit private organizations. And in this column chart we can see that a lot of, so we have Texas recorded the most hospitals, and out of which acute care hospitals are 315, followed by critical access hospitals, and that goes, the same goes with all the other states. So this was it from our group. We are open to any questions. Thank you for listening.
Great work. I have a question regarding the talent job. So you've used two inputs in one of the jobs. So have you used any filtering there?
Hi, thank you for the question. So yes, as I think you are talking about the disease collection. Let me open the, yeah. So here,
This is
this is
city
the
and
one,
disease,
right?
yeah.
So disease city and disease we are using just so that we can create a lookup between these. So we had a disease city CSV, which had all the diseases and the cities that these diseases were recorded in. And the disease CSV includes just the disease code, the disease name, and the description of of the disease. So we wanted to have the collections, have all the fields in the collection. So here, while we did the lookup, we got the yeah, in this one. So we have the disease, that is the treatment code, and the disease, and the description is what we got from the disease CSV. So that's the reason we did a lookup between these two CSVs.
Got it. And did you face any difficulties during the project? What was the most challenging part?
um, the most challenging part that we found out was the MapReduce, writing the MapReduce code. So for that, we learned a lot about how the mapper function emits key value pairs, and how this key value pair is fed into the reducer. So we can create all these aggregations using the aggregation pipelines as well, but to experience the true capabilities of MapReduce, I think a larger data set would be ideal. But having said that, I think these code will work just as efficiently with a larger data set.
Okay, thank you.
Yeah.